Dear students, let us go to the next question, question number 2. See, right now in the previous question, we have found whether those numbers or the given fractional numbers, how to understand whether they are rational or irrational just by observing the denominator part, right? We will how did we done that one? Just by taking the prime factorizations of the denominator part, and if the denominator part it's in the form of 2 raised to m into 5 raised to n, then that particular fraction or the given fraction will be a rational number. If it is not of that form, that will be irrational number. Clear? So that is what we have studied right now. So in the next question, see here in this question what we have to do, in the heading itself it's very clearly written in the question number 1. That means right now which the questions we have done 10 questions. So in these questions we found that some of them are rational numbers. That means they are terminating numbers, right? They are terminating, and some are non-terminating numbers. So let us collect these terminating numbers in question number 1. So from these terminating numbers, what we have to find? We have to find the decimal expansion. That means exactly we have to divide them, and we have to find after how many digits after the decimal place the particular so given number is going to terminate. So as I told earlier, in 9th class we used to divide them and check it out, but right now in the previous exercise what we have done without dividing, just by seeing the denominator part we could come to a conclusion that whether it's gonna terminate or whether it's going to non-terminate and recur. Right now we studied about that one, right? So here another question, it is given like this, that you have to find the decimal expansion if it's terminating. So let's go to the first question. While I'm explaining the question number 1, I will give you more explanation so that very fast you can understand that one. Okay, so here goes the question number 1. So question number 1 of question number 1, you can see that one there, 13 divided by 3125. That was the question given for us. So how did we check it? We checked the denominator part, and we could find that the denominator part is of the form 5 raised to 5, right? That means it's of the form 5 raised to m, like that. So if it is of the form 5 raised to m, then what did we concluded? We concluded that the particular number is a terminating decimal, and now this question is that you have to find the terminating decimal, means after how many digits is exactly it's going to terminate. That's what we are going to find. So normally what will come into our mind? We can check whether it is terminating or non-terminating, but how can we find the exact decimal places without dividing? That's the key point which I am going to discuss today about. See here, let us focus on the denominator. Every time, forget not, we are focusing on the denominator part itself. Now, here what is the denominator? 3125. In the previous question, already we have factorized that and we found it. It can be written as the powers of 5. That means it's written as 5 raised to 5, right? 5 raised to 5 is what 3125 is. Now, we can write this fraction. How can we write this fraction? We can write it as 13 divided by 5 raised to 5. Okay, now listen to this point very carefully. This is the main thing which you have to keep in your mind. Okay, so if you understood this one very fast, you can do each and every questions without further divisions. Means there is no need to exactly divide it and find it after how many numbers it's going to terminate. Very fast we can. See here, focus on the denominator part. What is the denominator part? 5 raised to the power of 5. 5 raised to the power of 5. Just neglect the numerator part, just throw it away from your mind. Just focus on the denominator part, okay? Now it is 5 raised to the power of 5. So we know that if it is a terminating decimal, we have to make it as the powers of 5 and 2. So here it's only of the power 5, 5 raised to 5. Now if you are bringing 2, you have to multiply it with 2. That's the first thing you have to understand. On the denominator part, 5 should be there, 2 should be there. This thing you have to keep in mind. 5 should be there, 2 should be there, and both of them both of the numbers, I mean 5 and 2, they should have the exact same powers. Means both of them, they must have the same powers. So anyhow here 2 is not there, so we have to introduce a 2 on the denominator part. I mean, we have to multiply the denominator by 2. It's not only 2. Here you can see what is the denominator. It's 5 raised to the power of 5. So what is the power here? It's 5, right? It's 5. So what you have to do, this 5, this same power you have to give to 2 also. So what will be that number? That number becomes 2 raised to the power of 5. That means you have to multiply the denominator part by 2 raised to 5. So in 9th class, in chapter number 5 of Euclid's theory, we have studied that if you are multiplying a particular number on the denominator, you have to multiply the same number on the numerator part also, because then only the fraction or the value of the fraction will be unchanged. It will be remaining as the constant as it is. So without making any further changes for the given fraction, what we have to do, if you are introducing, anyhow we have to introduce 2 raised to 5, means we have to multiply the denominator part by 2 raised to 5. Is that clear? And now if you want to multiply the denominator part by 2 raised to the power of 5, what should we do? We should multiply the numerator also by 2 raised to the power of 5. Then only the value of the given question will remain constant. Or else, if you are simply multiplying the denominator part only by 2 raised to 5, it will become something and something, right? The fraction becomes something else. So the value of the fraction should not change. You already know that if a fraction, say a and b, a by b, it's a fraction. If you are multiplying the numerator and denominator by a same number, just imagine you are multiplying the numerator by 2, and if you are multiplying the denominator also by the same 2, there is no changes. In the fraction, nothing is going to change, right? The fraction remains constant. You know that. That's the basics of fractions which we studied in our small classes. Similarly, so here, one thing we understood. What we understood? We have to multiply the denominator part by 2 raised to 5. So what should we do the next step? We have to multiply exactly the numerator by the same denominator. So here, that's why in the next step what we will write, that's equal to 13 into 2 raised to the power of 5 divided by, here already 5 raised to 5 is there, so 5 raised to 5 into 2 raised to 5. Is that clear? Then again is equal to, now you have to multiply the numerator part. What is the numerator part? 13 into 2 raised to 5. What is 2 raised to 5? It is 2 multiplying 5 times. When you are multiplying 2 5 times, what will we get? We will get 32. So 32 into 13. What's it? 32 into 13. How much it is? It is 416. Keep it there. 416 divided by. What about denominator part? Now focus on the denominator. Here you can see 5 raised to the power of 5 is there. 2 raised to the power of 5 is there. Both of them are having exactly the same powers. So you can join them together. In our 9th class, in the second chapter of polynomials, we studied about some algebraic identities and some algebraic expression towards the last of the chapter of polynomials. What was it? Just recall that one. Just recollect that one. Yes, that means a raised to the power of m into b raised to the power of m. Means both of them are having the same powers, but the base are different. One is a, another one is b. So if a raised to m into b raised to m is given, then together we can write ab the whole raised to m. Here we are going to apply the same theory here. So here it is 5 raised to the power of 5 into 2 raised to the power of 5. So how we will write? 5 into 2 the whole raised to the power of 5. Clear? So now coming to the last point. So now multiplying the numerator, what you got? 416 divided by, now what is this one? 5 into 2 the whole raised to the power 5. What is 5 twos are? 10. 10 raised to the power of 5 means, after 1 you have to write 5 zeros, exactly 1 lakh, right? Now dividing by that number, what you will get? Instead of dividing by 1 lakh, you have to bring 5 places behind and just put the decimal there. So now here you got 416. Now here you got 416. So from counting from the right towards the left, 1 point, then again another point, third point. So now the point reached till 4. We covered 3 numbers. We have to cover 5 numbers. So again 2 more. That means we will add 2 more zeros. So the answer will become point. Tell me. 0.00416. Forget not, after a decimal place, never read that number as 416. Even though if you just imagine that if you got an answer as 0.53, you will never read as 0.53. Okay, it's wrong. The pronunciation is wrong. You have to express as a 0.53. Clear? Like that. After the point, one by one, you have to read the numbers. Individually, you have to read the numbers. It's not together, all together, you cannot read the number. It's not a good form. Okay, so keep this in your mind. So what is the answer right now? It's 0.00416. That means without exactly dividing anything, just by multiplying so as to get the numerator, we got the answer, right? So this is the method. It's very easy, I think so. Going to the second question. Here in the previous question, you know, the second question also was a terminating. So we are going to take that question also. Let us take question number 2. What is question number 2? 17 divided by 8. Come on. Factorize we have already done that in the previous question. So 8 means we can write it as 2 cube. That means 17 divided by 2 cube. So here 2 is there, 5 is not there. What we have to do? Tell me. We have to multiply the denominator by 5. Not only by 5, we have to multiply by 5 cube. Why 5 cube? Because here it is 2 cube. So the powers should be exactly the same. Clear? So if you want to multiply the denominator part by 5 cube, the numerator part also should be multiplied by the same number. So what will become the number? 17 into 5 cube divided by 2 cube into 5 cube. Now join the denominator part. Bring the 5 and 2 together. So that's equal to 17 into, what is 5 cube? It is 125. So 17 into 125 divided by, what about bringing them together? 5 into 2 will come together, right? 5 into 2, the whole raised to 3. So what is 5 into 2? It is 10. 10 raised to 3 means it is 1000. So we can write 7 into 125 divided by 1000. What is 17 into 125? It is 2125. So 2125 divided by 1000. So instead of dividing by 1000, bring 3 places back and count 3 places back from the right and just mark the point there. So the number becomes 2.125. That's the answer. Next question. It's question number 3, right? In the previous exercise, you understood that question number 3, it is non-terminating. So we are not going to use that question. Let's jump to the next question. Question number 4. That is terminating, right? So we are using that same question here. So what is that question? 15 divided by 1600. 15 divided by 1600. Okay. Now 15 divided by 1600. There is no need to focus on the numerator part, focus on the denominator part. How will you write 1600? We have already done in the previous question. How we factorize that one? How we factorize that one? It is 2 raised to 6 into 5 square. Keep it like that. Now here, this is a typical question. See here. In the previous 2 questions, in the first question only 5 was there on the denominator part. So as we added 2 also. In the second question only 2 was there in the denominator part, so we added 5 also. Now see here 2 also is there and 5 also is there. Both of the numbers came together. But what about the powers? Powers are indifferent, right? I hope you noticed that one. Powers are different. See here 2 raised to the power of 6 and here it is only 5 square. Now here is the trick how to do this one. See, in these 2 powers, which is the greater power? 6 is the greater power. That means you have to bring both of them to 6. Keep this in your mind. Anyhow 2 is there, 5 is there. Now the only thing is that there is no need to bring any more 2 from outside or 5 from outside. Only the main thing is that check the powers. Now while checking the powers, what you understood? The powers, they are different. Take the bigger power. Here it is 6. So bring both of them to the same power. That means 5 square. It's already 5 square is given. You have to bring this 5 square. You have to make it as 5 raised to 6. How can you make it? If 5 square is there, if you want to make it into 5 raised to 6, that means you have to multiply that by 5 raised to the power of 4. Then only 4 plus 2, 6 will come. Right? So that means you have to multiply the denominator part by 5 raised to 4. Keep this in mind. If you want to divide, if you want to multiply the denominator part by 5 by 4, then the numerator part also should be multiplied exactly by the same number. That means by 5 raised to 4 itself. So let us multiply the numerator and the denominator by 5 raised to 4. Clear? this is the way how to choose the exact number which should be divided on the denominator part. Hope you understood it very clearly, right? Okay, now next line, that's equal to, here already the numerator is given as 15. So 15 into 5 raised to 4 divided by 2 raised to 6 into 5 square into 5 raised to 4. Next line, that is equal to 15 into, what is 5 raised to 4? It is 625, right? So 15 into 625 divided by, now see here, 2 raised to 6 into, instead of 5 square and 5 raised to 4, together I can write 5 raised to 6, right? That's why we brought all these things. Okay, now we will write like this, 2 raised to 6 into 5 raised to 6. Next line, 15 into 625 divided by, this 5 and 2 we will join together, right? 5 2s are 10. So 10 raised to the power of 6. That means 10 lakhs. Now the number becomes, that's equal to 15 into 625. What's it? 9,375 divided by 10 lakh. 10 lakh means there are 6 zeros. Just count the zeros. There is no need to get disturbed when you are seeing such a big number. How to divide by this big number? There's nothing. Just count the zeros, right? You know that method, I know. Just by counting the zeros, how many zeros are there here? There are 6 zeros. So that's why what you have to do? You have to count back 6 decimals, 6 points or 6 numbers from the right. So counting 6 numbers, what will be the final? And then you have to put the decimal place there. Now what will be the number? It's a 0.009375. See, 0.009375. Even though I said 0.00, in front of point we will put 1 0, forget not. 0 point, like that we will write 0.009375. But we will, when we are pronouncing, we will not use that one. We will simply say 0.009375. But when we are writing, you have to introduce a 0. It's normally like this, that most probably when you are putting in decimal place, there are chances that the teacher may not notice that 0 there, or even the students also when they are writing itself. Unfortunately, you know that plenty of times you are using the pen from here and there, and you may be pointing unnecessarily here and there, and sometimes it occurs that a point by mistake may be there in the in any part of your paper. So if you are knowingly, if you are putting a point, that means if you are meaning that you want to express a decimal there, you want to introduce a decimal there, knowingly you will put a 0 there, so that that decimal will be projected much more. That's the only why we are using the 0 in front of this. Nothing more is there regarding that one. Okay. What is the next terminating decimal? It's question number 6. What is question number 6? 23 divided by 2 cube into 5 square. Now you are very easy, right? Now I think you are very very happy to understand that. You know the trick, right? Now you can understand that how to do this one. Tell me. Now looking on the denominator part, what you understood? Here it is 2 cube into 5 square. So 2 and 5 are there. 2 cube, 5 square, which is bigger one? 2 cube. Cube is bigger one, right? So both of them must have the same powers, 3 itself. Here it is only 5 square. So if you want to make 5 square 5 cube, what you have to do? Multiply by 5, that's enough. That means multiply the numerator and denominator by 5. Okay, now next step. 23 into 5 divided by 2 cube into 5 cube. That is equal to 23 into 5. How much it is? How much it is? It is 115 divided by, come on, 2 and 5 when you join it together, it will become 5 2s are 10. 10 cube. 10 cube means 1000. So 115 divided by 1000. How much it is? 0.115. That's it. Next question is question number 8. 6 by 15. Here it is not in the simplest fraction. Bring it to the simplest fraction. If you are bringing to the simplest fraction, what will it become? It becomes 2 by 5. Now 2 by 5, it's very easy. Already there is a 5. Now we have to introduce a 2 also. Here what is the power of 5? It's 1 itself. So it's easy. Just multiply numerator and denominator by which number? 2. Exactly. 2. So numerator and denominator, when you are multiplying by 2, what will become? 2 into 2 divided by 5 into 2. 2 2s are 4 divided by 5 2s are 10. Instead of dividing by 10, put one place back, put the point there. What did you got? 0.4. That's it. It's so easy, right? Okay, next one more. The final question of this section, because that was the last terminating decimal which we found in question number 1. Next question is question number 9. 35 divided by 50. as I said right now, this is also not of the simplest form, right? Let us bring it to the simplest form first. So cancelling the numerator and denominator by 5, what you will get? 7 by 10. 7 by 10. Now check out the denominator, it's 10. 10 means 2 into 5. Oh, it's so easy. 2 into 5 means 2 and 5, both of them came. And what about the powers? If you saw both of the numbers, next your eyes should go on the power side. So now check out the powers. Both of them are having the same power, right? 1 itself. It's nothing to worry about, nothing to do. Very fast you will get answer in the single step itself. Now we will write 7 divided by 2 into 5. So 2 into 5 is 10 itself. So that is 7 by 10. Instead of dividing by 10, we will write that's equal to 0.7. That's the answer. So this is the way how to find the terminating decimal of a given fraction without by division. Here I think you have noticed that we haven't divided even once. Did you divide even once? No. Without division, you got the answer. Forget not, this will only happen for terminating decimals, only for terminating rational decimals. Okay, forget not. Okay, so this is the way how to form this one, how to find this one. Hope you understood. The very last question of chapter number 1. Here you can see there are 3 questions given. You have to do one thing. First of all, you have to say whether these numbers are rational. That's the first thing. Second thing, if it's a rational number, what can you comment about the denominator? That's the second thing. So see, if you are seeing a number and if you want to say whether it is rational or not, you must know about how to express, means how to understand whether a given decimal is rational. What was it? We have discussed about this in the previous video. What was that? Just recall that one. What was that? It was like this, that if it's a rational number, point number 1, it will be a terminating decimal. Means after some points the decimal place will terminate. After the decimal place, after some numbers, the number will terminate. It will be a terminating decimal. Second thing, it will be, or it can be the second case for a rational number when you are finding the decimal expansion of the rational number. Second case, case number 2, what was the second case? It can be a non-terminating but repeating one. It should be a non-terminating and repeating. That means if it is not repeating and if it is not terminating, that's what we call irrational. So keep in your mind this one, okay? So you have to find these 2 things. By these 2 things you are going to check it out. Question number 1. What is question number 1? 43.1, 2, 3, 4, 5, 6, 7, 8, 9. Tell me whether it is a terminating decimal or non-terminating. Definitely it's terminating, right? After these 9 numbers, it terminated, it came to an end. That means it's a terminating decimal. If it's a terminating expansion, it means that that's a rational number. Clear? It's a rational number. Okay, we got it. Now, what can you comment about that rational number's denominator part? What can you comment about the denominator part? If it's a terminating decimal, definitely, what can you say? The denominator is of the form 2 raised to m into 5 raised to m. So 2 raised to m into 5 raised to m. The denominator will be of the form 2. Then only it will terminate, right? Right now we've done it. So we can comment like that definitely, as we understood that this is a terminating decimal, we came to the conclusion, we came to the conclusion that it's a rational number. That means if you are changing or if you are bringing back this to a rational number, which we have studied in 9th class about how to bring back a terminating decimal to rational number. You have studied in 9th class, right? So if you're bringing back this to the terminating decimal, if you're bringing back this to a fraction, I mean a rational number, definitely you can understand that the denominator part will be of the form 2 raised to m into 5 raised to n. That's it. Second question, check out the second one. 0.1201, 2001, 20001, 20001, and it is continuing like that. Towards the last you can see there are 3 dots. What does it mean? It's a not terminating. That much you understood. It's not terminating. Not terminating means it can be rational number, it can be irrational number, right? It's non-terminating, that much we understood. If it is not terminating and if it should be a rational number, then it should be a repeating one, right? It should be repeating. That's it. So just check it out. Anyhow, you found out that it is not terminating. Now let us check it out whether it is repeating. See here, is it repeating? You can see here itself. First you can see 1 0, then you can see 2 zeros, then you can see 3 zeros, then 4 zeros. That means it's not repeating. It's increasing some way. It's not repeating. It's not recurring. It's not going in a rhythm. It's simply increasing and going. So what can we conclude? We can say that it's non-terminating and non-repeating. In other words, non-terminating, non-recurring decimal. That means it is an irrational number. It's not rational. So what about the denominator part? The denominator part will be not of the form 2 raised to m into 2 raised to n. Right? 2 raised to m into 5 raised to n. It will not be of that particular form. That's why it became non-terminating, non-repeating. That's it. Final question, the last one of this section. Check out. 43.1, 2, 3, 4, 5, 6, 7, 8, 9, and on the top of this one you can see a bar. It's called bar. It's read as bar. So whenever you are seeing this bar, what does it mean? It's repeating. Whenever repeating numbers are there, we will put this symbol, right? In 9th class we studied. All these things actually, they came from 9th class, means the base lies there itself. So it's very easy that you already covered that one. So here you can see the base is there. That means the bar is there. It's not base. So here already you can see the bar is there. Bar is there means the number is repeating. So what about if it is a repeating decimal? Definitely it is a rational number. And we can conclude, as it is a rational number, the denominator part will be of the form 2 raised to m into 5 raised to n. That's it. So I hope you enjoyed the video. Forget not to subscribe our channel and keep on watching our channel. And if you're having any doubts regarding any of the question, you can comment down below and we will check it. And definitely we will revert you as soon as possible. Hope you enjoyed the video. And this is all about chapter number 1 of real numbers. Next, in the next video, we will meet with a new chapter, polynomials.